This is 4-4 congruent triangles. So let's start with the warm-up. Number 1, name all sides and angles of triangle FGH. So it might help to actually just draw a triangle with the vertices FGH. And now I can see all the angles would be angle F, angle H, and angle G. And all my sides are segments, so I'll say segment FH, segment HG, and segment GF. Okay, warm-up number 2. What is true about angle K and angle L? Well, angle K and angle L must be congruent to each other because of third angle's theorem. So angle K is congruent to angle L by the third angle's theorem, which is in 4-3, and it states that if two of the angles of a triangle are congruent, then the third must be congruent. What does it mean for two segments to be congruent? They would be the same length. Okay, and what makes two geometric figures congruent? To have two geometric figures congruent, we would need to have all segments and angles be congruent. Okay, this can be kind of overwhelming to look at, but if we're looking at some congruent polygons, remember they're all sides and angles congruent, then we really want to just see like that angle A is congruent to angle D because they both have one arc mark. Angle B is congruent to angle E because they have two arc marks, and angle C is congruent to angle F because they have three arc marks. So that's all labeled here. And then we also have side lengths. So segment AB is congruent to ED because they have one congruent tick mark. And then segment AC is congruent to segment DF because they have three congruent tick marks. And BC is congruent to EF because they have two congruent tick marks. Okay, and it's the same idea in the rectangle. I do want you to notice that when we name a polygon, we do it with the vertices in consecutive order. So if I start naming this first rectangle, let me show you what I'm pointing at. This first rectangle right here, if I'm going to name this rectangle, then if I decide to start at P, for instance, and I go towards Q, then I can't jump to S next. Someone said one time it's like train tracks. If you start at P and you go to Q, then you would have to name the next one is R, S, okay? And it eventually closes up. So we can name this polygon PQRS, but you could have picked a different starting point. You could start at R, for instance. If I start at R and I decide to go to Q, then I would say RQPS. Okay, and when you're naming two figures being congruent to each other, make sure you do so in the correct order. So let me show you what I mean. If I am starting with angle A in this triangle up above, if I start with angle A and I decide to name this triangle A, B, C, I want you to notice that I went from the first arc mark. So A would match D, and then from there I went to B, which had two arc marks. So I'm traveling towards E, the angle that has two arc marks there. So if I called this triangle ABC, then I need to call the next triangle DEF, so that when I look, my A matches my D because those are congruent. My B matches my E since those had two congruent arc marks. And angle C matches angle F since they had three congruent arc marks. Okay, so it says if triangle PQR is congruent to triangle STW, then identify all pairs of congruent corresponding parts. So it might help you to draw this out. So if PQR, for instance, is congruent to, and I'm going to make sure it matches up, STW, So P is congruent to S, Q is congruent to T, and R is congruent to W. Okay, so that then, for instance, in between the 1 and 2 arc marks, I'll put a 1 congruent tick mark. In between the 2 and 3, I'll put 2 congruent tick marks. And in between the 3 and 1 arc mark, I'll put 3 congruent tick marks. So then it's pretty easy to label the angles and sides that match. Let me start with angles. So my angles would be the angle P is congruent to angle S, angle Q is congruent to angle T, and angle R is congruent to angle W. And now for the sides, we would have segment PQ is congruent to segment ST. Then I could say segment RQ is congruent to segment WT. And segment PR is congruent to segment SW. And notice it makes sense in my actual, in my congruent statement up above here. So like, for instance, PR matches SW in that order. It's the first and last of my congruent statement. Or I could say, for instance, QR, I already know it should match the segment on the right, TW. And so I can check that. QR matches TW, or RQ matches WT. Same idea. Okay, now you try. If polygon LMNP is congruent to polygon EFGH, identify all pairs of corresponding congruent parts. Well, just notice that it's 4 vertices, so these are quadrilaterals, so I know I'm going to have 4 congruent angles. So without even drawing it, I'm just going to say that angle L is congruent because it's matching E, angle E. Angle M is congruent to angle F. Angle N is congruent to angle G, and angle P is congruent to angle H. And now for the sides, think about this. LM is congruent to EF. And MN, the next interval, is congruent to FG. And NP is congruent to GH. And the last one would be PL is congruent to HE. And if that's a little challenging for you, just draw the 2 rectangles or quadrilaterals. Okay, now we're going to use our corresponding part. So it says that triangle ABC is congruent to triangle DBC. Find the value of x. Well, I see x is right here, so I'm trying to see if I know anything about this angle. Well, I do know that it must be 90 degrees because of the linear pair right here. So I can just set that equal to 90 degrees. 2x minus 16 equals 90. 2x, I'm going to add 16 to both sides to get 106. And therefore x equals 53. So the value of x is 53, and you could plug that back in and check to make sure that we get 90 degrees there. Measure of angle DBC now. Well, DBC would be really like an angle B. And I know that A matches D based on my congruent statement above. So D must be 49.3, angle D. And now this is the corollary of a right angle, that these 2 angles add up to 90 degrees, or the whole triangle adds up to 180, however you want to think about it. So I know I can just do 90 minus 49.3. 40.7 degrees. So the measure of angle DBC then is equal to 40.7 degrees. Okay, now you try. Triangle ABC is congruent to DEF. You might want to redraw this so that the DEF are lined up properly. So I know that A is supposed to match D. And I know that the B from the congruent statement is supposed to match the E. So I'll put E up here, and I also know that it's 53 degrees since I know B is 53. And I know that C is supposed to match F, so I'll put my F here. We knew that DE was 6 and EF was 10. I'm just taking that from my image in case we need that. All right, it tells us to find the measure of angle F now. Well, measure of angle F, since we already put in our 50, this is the corollary again. I can do 90 minus 53, and I get 37 degrees. So the measure of angle F is equal to 37 degrees. Sorry, I don't know why I skipped example A. Find the value of x. Well, the value of x, I'm looking at my BA, which is supposed to, according to the congruent statement, BA should match DE. Well, BA is 2x minus 2, and DE is 6, so I can set them equal to each other. 2x minus 2 equals 6, add 2 to both sides, 2x equals 8, divide by 2 on both sides, and x equals 4.